Energy is not just electricity coming from a wall socket. It is heat in our homes, light in our cities, factories, transportation, communication, medicine, computing, and spaceflight. Energy is the foundation of civilization. Without it, humanity would not simply stop progressing. It would very quickly find itself struggling to survive. And if other intelligent civilizations exist somewhere in the universe, they likely face the same question. Where do we get more energy? Not enough energy for a city, not enough for a single planet, but enough for an entire civilization. One that grows, builds, explores space, and perhaps one day expands beyond its home star system. One of the most famous answers to that question is the Dyson sphere, a hypothetical megastructure that could collect the energy of a star. But in recent years, an even stranger version of this idea has been proposed. What if an advanced civilization built something like a Dyson sphere, not around a star, but around a black hole?
Hi, my name is Liam, and you're watching Cosmic Nomad. Today, we're diving into an idea that sounds like pure science fiction. Dyson spheres, civilizations harvesting the power of stars, and even megastructures built around black holes. But the fascinating part is that this is not just fantasy. It is a real scientific concept that has been discussed by physicists, astronomers, and researchers involved in SETI, the search for extraterrestrial intelligence. So let's start with the basic question: what exactly is a Dyson sphere?
In 1960, physicist Freeman Dyson published a short but influential paper in the journal Science titled "Search for Artificial Stellar Sources of Infrared Radiation." The main idea was not to give humanity an engineering blueprint. Dyson was thinking about something else. If a highly advanced civilization learned to use a large fraction of its star's energy, that activity should leave behind a detectable signature. Any system that collects starlight cannot escape the laws of thermodynamics. The energy does not simply vanish. It is collected, transformed, used to do work, and eventually some of it must be released as waste heat. That heat would radiate into space as infrared light. So Dyson suggested that astronomers should look for unusual infrared sources. A star that appears unusually dim in visible light, but unusually bright in infrared could, in theory, be surrounded by artificial structures. Later, these hypothetical structures became known as Dyson spheres. But it is important to understand something. Dyson was not necessarily imagining a perfect solid shell around a star. The more realistic version would be a swarm of objects, collectors, habitats, mirrors, power stations, or orbital platforms, all working together to intercept a significant fraction of a star's energy. So the word sphere can be misleading. A Dyson sphere does not have to be a literal sphere. It can mean any enormous system built by a civilization that has learned to harvest the power of its star on a massive scale.
This is where the image in our heads can get us into trouble. When we hear Dyson sphere, we immediately picture a giant metal shell wrapped around the sun, like someone took a star and sealed it inside an artificial world. It looks amazing, but the real idea is more subtle. Dyson was not just talking about construction, he was talking about detection. If someone out there is using the energy of a star, they still have to dump heat somewhere, and that heat might be visible to us. So a Dyson sphere is not only a megastructure, it is also a possible technosignature, a sign of technology that astronomers can search for in telescope data.
Dyson's idea did not appear out of nowhere. He openly acknowledged that he was influenced by science fiction, especially Olaf Stapledon's novel Star Maker, which imagines civilizations on truly cosmic scales. In the 20th century, these ideas began to intersect with more formal scientific thinking about the development of civilizations. In 1964, Soviet astrophysicist Nikolai Kardashev proposed a way to classify civilizations based on the amount of energy they could use. A Type 1 civilization uses the energy available on its home planet. A Type 2 civilization uses the energy of its star. A Type 3 civilization uses the energy of an entire galaxy. A Dyson sphere fits perfectly into the idea of a Type 2 civilization. If a society can build infrastructure around its star and collect a significant portion of its power, it has reached an energy level almost impossible for us to imagine. The sun produces roughly 4 times 10 to the 26 watts of power. That number is so enormous that all of modern human civilization looks almost invisible beside it. But for a civilization that has survived thousands or millions of years of technological development, the energy available on a single planet may no longer be enough. At that point, the star becomes the obvious resource.
What I love about this idea is that it is both insane and logical. If a civilization keeps growing, it needs more energy. First, it burns wood, then coal, then oil and gas, then nuclear power, solar power, maybe fusion, if it ever becomes fully practical.
Errors could destabilize the system. The third version is the Dyson shell. This is the image most people know from science fiction, a continuous solid sphere surrounding a star. Such a structure could, in principle, intercept nearly all of the star's radiation and provide an enormous inner surface. But this is also the version with the biggest problems.
If we're being honest, the solid shell is the best version for posters and the worst version for engineers. A Dyson swarm is at least imaginable. Lots of satellites, lots of collectors, built gradually over time. But a solid shell around a star, that is an orbital mechanics nightmare. Where do you get that much material? How do you keep it stable? How do you repair it? How do you stop it from drifting? And the most basic question of all, how do you even begin building something the size of Earth's orbit?
If we imagine a Dyson sphere around the Sun at roughly 1 astronomical unit, its radius would be about 150 million kilometers. Even if the shell were incredibly thin, the amount of material required would be beyond anything humanity can currently access. Some estimates suggest that building such a structure would require dismantling entire planets or large parts of the inner solar system, perhaps Mercury, asteroids, and possibly other bodies. But material is only one problem. A rigid shell around a star would not automatically be stable. If its center shifted even slightly away from the star, gravity would not simply pull it back into place the way it does with an orbiting planet. The displacement could grow worse. The structure would also be constantly hit by dust, meteoroids, asteroids, and comets. Any huge system needs maintenance, and maintenance on the scale of Earth's orbit becomes almost endless. There is also the issue of living on the inner surface. Science fiction often shows people living inside a Dyson shell, under the light of the enclosed star. But gravity would not behave like it does on the surface of a planet. Comfortable habitation would require rotating sections, artificial gravity, or separate living modules. That is why most serious discussions today focus less on a solid shell and more on swarms or networks of independent structures.
And this is a great example of science fiction and science talking to each other. Science fiction gives us the powerful image, a giant sphere around a star. Science comes in and says, beautiful. But let's talk about gravity, materials, heat, orbits, and repairs. And after that, the idea does not disappear. It becomes more realistic. Not a giant shell around the sun, but an enormous network of collectors and stations. Maybe less dramatic visually, but much closer to physics.
But if a Dyson sphere around a star is already an extreme idea, a Dyson sphere around a black hole sounds even stranger. A black hole has no solid surface. It does not shine like a star. The event horizon itself emits no light that can escape. But around a black hole, there may be an accretion disk, superheated matter spiraling inward, accelerated to enormous speeds and radiating vast amounts of energy. Some black holes also have coronas, powerful magnetic structures, and relativistic jets, narrow streams of particles launched at nearly the speed of light. These regions, not the black hole itself as a dark object, could become sources of energy. In 2021, an international team of researchers explored the theoretical possibility of a Dyson sphere around a black hole. They considered several potential energy sources: the cosmic microwave background, Hawking radiation, accretion disks, interstellar gas accretion, coronas, and jets. They found that for a black hole with an active accretion disk, the available power could be enormous, in some scenarios, far greater than that of an ordinary star. But that does not make the project easy. A black hole is one of the most dangerous objects in the universe. Near it, there may be lethal radiation, extreme tidal forces, unstable flows of matter, and violent, high-energy processes. Harvesting energy there would mean building next to a cosmic monster.
That sounds like a project for a civilization that has stopped being afraid of almost everything. We sometimes argue about where to put solar panels on a roof. And here the idea is, let's build energy infrastructure around a black hole. But the logic is there. Black holes can be incredibly efficient energy machines if matter is falling into them. An accretion disk can radiate an enormous amount of power. The price is the environment. It's like building a power station not next to a volcano, but inside a hurricane that bends space-time.
Some people also suggest that a black hole could be the ultimate place to dispose of waste. In a very narrow sense, that sounds reasonable. Once something crosses the event horizon, it does not come back out. But real physics is more complicated. To throw waste into a black hole, you first have to deliver it there. That requires energy, navigation, and protection. And any object falling into a black hole increases its mass and may interact with surrounding matter before crossing the horizon. A black hole is not a trash can in the ordinary sense. It is an extreme gravitational object, and using it safely would require a level of technology far beyond anything humanity can imagine building in the near future. For a Type 2 or Type 3 civilization, such ideas might be worth considering. For us, they remain theoretical astroengineering.
I think the word theoretical really matters here. It keeps us from making claims that are too strong. We are not saying that civilizations definitely build Dyson spheres around black holes. We are saying that if you imagine a civilization with an almost unimaginable level of technological ability, physics allows us to at least discuss scenarios like this. And then the next question becomes, could we ever detect such structures?
If a Dyson sphere exists, it should leave observable signs. The main one is excess infrared radiation. Any structure that absorbs starlight must eventually re-radiate that energy as heat. So astronomers search for objects that look unusual. Too much infrared light, strange brightness, or a spectrum that does not match a normal star. These searches have already been attempted. Infrared sky surveys and data from missions such as WISE, Gaia, and 2MASS have been used to look for possible candidates. In 2024, Project Hephaestus identified several objects with unusual infrared excess that deserve further study. But that does not mean we have found alien megastructures. Infrared anomalies can have natural explanations: dust, debris disks, background galaxies, measurement errors, unusual stellar activity, or contamination in the data. Some candidates have already been given possible astrophysical explanations. At this point, we have no confirmed Dyson sphere, not around a star, and not around a black hole.
And that needs to be said clearly. Candidate does not mean aliens. Science does not work that way. If an object looks strange, you have to test it. Rule out dust, rule out background galaxies, check the spectrum, compare data from different telescopes, see whether the signal is repeatable. But the idea of searching for technosignatures is incredibly powerful, because we are not waiting for a radio message that says, "Hello, Earth." We are looking for the consequences of technology: heat, light, anomalies, energy footprints. If a civilization becomes large enough, maybe it cannot completely hide its infrastructure.
Of course, many scientists doubt that a classical Dyson sphere could ever be built. Astronomer Zaza Osmanov, for example, has explored more compact forms of megastructures, not complete spheres, but rings or structures around unusual objects such as pulsars. Pulsars are rapidly rotating neutron stars that emit powerful beams of radiation. In theory, a civilization could attempt to harvest that energy using a ring-like structure. This also sounds fantastical, but in some ways it may be more realistic than a complete shell around an ordinary star. Still, even smaller megastructures face many of the same challenges: materials, stability, radiation, construction, maintenance, transport of mass, and control of enormous infrastructure. So for now, Dyson spheres remain not an engineering plan, but a scientific hypothesis, a thought experiment, and a possible target for SETI. They help us ask a larger question: what would a civilization look like if it could use energy on the scale of a star?
And I think it's important not to laugh at ideas like this just because they are impossible for us today. To people in the 19th century, global electrical grids, satellite navigation, and fusion reactors would have sounded almost magical. But there is a difference between impossible today and forbidden by physics. A Dyson sphere is not necessarily forbidden by physics in the broadest sense. But it is so far beyond our current technology that for us it is not a project. It is a mirror. It shows us how small our civilization still is on the cosmic energy scale.
Ideas about megastructures also appear in discussions about humanity's future. One example is the O'Neill cylinder, a huge rotating space habitat designed to support human life beyond Earth. Such cylinders could create artificial gravity through rotation. Inside them, there could be cities, farmland, lakes, atmosphere, and controlled environments. Jeff Bezos has spoken many times about a future in which heavy industry moves into space and people live in large orbital colonies. Elon Musk, on the other hand, has criticized that approach, comparing the construction of huge space settlements in empty space to trying to build a country in the middle of the ocean instead of settling on planets. Each idea has its own logic. O'Neill cylinders offer controlled artificial environments. Planetary colonization offers natural surfaces, resources, and gravity, although with enormous difficulties. A Dyson sphere is even more extreme. It is not just a habitat, it is infrastructure on the scale of an entire star system.
I actually think these debates are useful. Bezos says, build large orbital settlements and move industry into space. Musk says, go to Mars and build a civilization on another planet. And Dyson, in a much broader sense, asked an even bigger question. What happens when a civilization outgrows its planet and begins using the power of its star? All of these ideas point in the same direction. If humanity survives and continues to develop, sooner or later, one planet may not be enough. The only question is, which path turns out to be real?
But at our current level of technology, a Dyson sphere is completely out of reach. We do not have the materials to build structures on that scale. We do not have the energy to move planetary amounts of matter. We do not have the space industry needed to manufacture billions of orbital components. We do not have control systems capable of maintaining a structure the size of Earth's orbit. Even a Dyson swarm, the most realistic version, would require an industrial civilization spread across much of the inner solar system. It would require mining Mercury, asteroids, or other bodies. It would require factories in space. It would require transmitting energy across vast distances. It would require controlling the orbits of billions of objects. preventing collisions, repairing damage, and protecting the system from instability. For us, this is almost unimaginably far away. But as a concept, the Dyson sphere remains extremely important. It shows that the search for extraterrestrial intelligence does not have to focus only on radio signals. We can search for signs of activity, waste heat from megastructures, unusual spectra, anomalous infrared sources, stars that do not behave the way stars should.
And to me, that is one of the most interesting approaches in SETI. We often imagine contact as a message. Someone sends a signal, we detect it, we decode it, we respond. But what if an advanced civilization is not sending us messages? What if it is simply living, building, consuming energy, and reshaping its star system? Then its signs may not be words, they may be heat, infrared excess, a strange star, or an object that first looks like an astrophysical mistake, until we realize it is something entirely new.
So far, we have found no convincing evidence of Dyson spheres. No star has been confirmed as artificially surrounded by a megastructure. No candidate has become proof of an alien civilization. But the lack of evidence does not make the search meaningless. On the contrary, these searches help improve astronomical catalogs, reveal rare types of stars, identify unusual infrared sources, and clarify what a real technological signature might look like. A Dyson sphere is not only a dream about an alien super-civilization, it is a way to measure the limits of possibility, the limits of energy, the limits of engineering, the limits of observation, and perhaps the limits of our imagination.
Humanity is nowhere near ready to build a Dyson sphere. We are still learning how to build sustainable energy systems on Earth. We are only beginning to create infrastructure in orbit. We are not mining asteroids. We are not building cities in space. But when we talk about Dyson spheres, we are not only talking about what we can do today. We are talking about what the distant future could look like, and about the possibility that somewhere in the galaxy, someone may have reached that future long before us.
If advanced civilizations exist, they may be nothing like us. They may not use radio signals. They may not build planet-based nations. They may not leave the kinds of traces we expect. But every civilization needs energy. Every intelligence, every technology, every machine must draw power from somewhere and release heat somewhere else. That is why Dyson's idea has survived for decades. It is simple but profound. Do not only search for signals, search for energy. For now, we look up and see stars. But perhaps one day, among those stars, we will find something that is not simply a star at all. It may be the signature of intelligence that learned to build on the scale of a solar system. And here's the question for you. What do you think is more likely? That an advanced civilization could one day build a Dyson sphere around its star? Or that megastructures like this are simply too difficult and intelligent civilizations will find a completely different path to energy? Let me know in the comments. And we'll keep looking into the darkness, because sometimes the most unbelievable ideas begin with a simple question. What if someone has already done it?